on which cryptography is based. So these are certain parameters that are required to be previewed before considering the concept of cryptography. Sir, next slide, please.
Yes.
Yes, thank you. So we'll have a review of these topics. Because cryptography is based on communication, we should have some concept of communication, or we'll just brush up the concept of communication. Communication can be expressed in basically two categories. Number one is wired communication, and other is wireless communication. So wired communication, as name indicates, have connectivity between two ends, let us say client and server. And the media of communication or channel of communication are so many. For example, in our electrical grid, the wired link is PLCC, or earth wire is used for communication. Now it is OPGW, new projects of optical fiber ground wire are coming in. Similarly, other things are there like coaxial cable or twisted pair, that is for small LAN installation, but it is also a connectivity between two computers. Then waveguides are also there. So this is all about wired, but the main thing today is wireless. So wireless media is only internet, and voice and data both can be sent through the internet media. There are three types of connectivities. One is peer-to-peer, means one-to-one connection. If there is a substation and if there is a SLDC or a monitoring station, CMS, central monitoring station, then one substation is connected to one CMS, that is peer-to-peer, which is not practical because we have got one CMS or two CMS, and there are number of connectivities, number of substations are there. At present in Mahatransco, there are 650 around substations. So it will be a master-slave type. Means one master is there, like CMS, central monitoring station is a master, and the substations are slaves, and substation will provide information to master. But the problem with master-slave model is that we cannot change the role, and we cannot change number of connections also. For example, if one master is there, you cannot increase number of master terminals. So that can be achieved through the very practical way of communication, and that is called client-server communication. So client-server communication is most adaptable type of communication all over the world today. All the models are client-server model. We can have example of Mahatransco grid, where SLDC at ALDC Ambazari and SLDC at Kalwa, they are playing the role of server. And number of substations are client substation. As I told, 60-50 around substations, these are client. So all the time, 24/7, they are going to send data to the server. So that is a sort of communication which is called client to server communication. Now the cryptography comes in picture here only, because the data that is sent is very important. If it is a ABT meter, then all the billing data is sent for billing purpose. And if the data is tampered, if the data is stolen, or if data is modified, then lot of loss of revenue will be there. Therefore, cryptography is implemented to deal with the issues related to theft or forging of data. So that is what cryptography is. The name crypto means it is made up of two words. Crypto means coding, and graphy means to write is a graphy, like biography. So coding of the means encoding the graphy, encoding the writing is called cryptography. So we'll study it later. So this is the initial definition of cryptography. Then we have layers of communication, which is the important parameter. Layers of communication, as name indicates, are imaginary layers. They are only related to the concepts. that tell us how the data is sent from one place to other. So there are 7 layers of communication. One is, let us say, application layer or program layer. Then presentation layer is there. Not programmable, presentation layer is there. Physical layer is there. Data link layer is there. Session layer is there. Transport layer is there. So all these layers are combined together to send data, and each layer plays important role. Now there are certain protocols. Protocol means rules of communication. So they will have some ideologies and some norms for flow of data. The important ones are TCP and UDP. So TCP stands for Transmission Control Protocol, and UDP stands for Unified Datagram Protocol. So these are playing same role of sending the data, but the TCP is faster and accurate. UDP is to some extent slow, but it can guarantee you that the data will be always sent. In case of TCP, there are some cases the data is not received in time, or some bits or some bytes are left around. That is not the case with UDP. Although UDP is slow, there is a guarantee that all the data is sent at the other end. There are other protocols also, like FTP is there, File Transfer Protocol. HTTP is there, that is a Hypertext Transfer Protocol, which is very common. We are using our websites, we are having our mail accounts based on HTTP. Now there is a HTTPS, where S stands for secure. So HTTPS is more secure than ordinary HTTP, and therefore HTTPS is being used. Now the other important thing is IP address. That is the basic of internet. If you want to send data from one end to other, for example, if you want to send data from numeric meter to SLDC, then I should know the address of SLDT, and I should know what is the data to be sent. Just like we are sending letter to somebody, whenever you write some letter, we mention address, and in the letter we write some description. So that is the same case with IP address. So there are packets in which the data is there and address is there. So that at that address, the packet will travel and it will reach that destination through the protocol called TCP or UDP. That is a simple way how the IP addressing is done. Now IP address is a dot code address, means there are 4 numbers and they are divided by dots, and each number is less than 256. I will explain the reason later. And that is dot code. It is difficult to remember data in terms of dot code. Therefore, we are abbreviating it in terms of name, like a DNS, means domain naming system. So you can give name instead of dot code, instead of number, and therefore it is easy to remember. For example, yahoo.com may have some dot code like 123.2126 or 0.007.123, say like that. So instead of remembering this address, IP address, I can call it yahoo.com, which is easy to remember. So IP address is important thing in cryptography. And second is port address. IP address for some device may be same. For example, if it is a PMU, it has got number of ports. Input port is there, output port is there. So these have got addresses. So IP address and port address are the two identities for sending and receiving the data. Unless we mention IP address and port address, the data cannot be sent. Just like a letter that we are sending to our friend indicating address and contents. So that is the analogy with IP addressing. Now coming back to our network. Sir, next slide, please. Coming back to our smart grid network, having smart grid communication. So this is the same network that we are having at our Mahatransco setup. Only the thing is that there are 2 types of smart grid communications. One is called AMR and other is called AMI. AMR stands for automated meter reading, which is unidirectional. And AMI is called advanced metering infrastructure, which is bidirectional. So at present, we have got AMI based communication, whereas in coming future, it will be in favor of AMI, not AMR. At present, it is AMR. The general setup of AMR is like this, starting with numeric meter. So this is the substation end, and the other end is a SLDC end or central server or CMS, whatever you call it. So there are two ends, substation end and CMS end. At substation end, the meters are installed. At CMS end, the server is provided, which receives the data all the time, 27/24 from substations. Substation numeric meter are there for sending data. Basically, ABT meter is there, which is sending ABT data. But data can also be sent through TOD meters or smart meters or any other meter which is microprocessor based. At present, the communication is taking place from ABT meter to CMS. And in all, there are 9,000 nodes where communication is going on all over Maharashtra. So such huge network is there for smart grid communication. RJ11 is the connector which is provided at the backside of numeric meter and which is connected to serial port. And it is connected to Modbus. And from Modbus, it is connected to DCU through Ethernet or other communication channel. DCU is a data concentrator unit where all the data is sent. Then onwards, the things are taken over by internet media through router, which is the internet switch. The data is sent to the CMS. At the same time, the data is also stored at the local substation, which is there at each substation as a backup data. Secondly, at the CMS, there is a DBMS. DBMS is a database management system server. Nowadays, there is a cloud server, which is storing the data received from substations. So this is one channel, which is a wireless channel or internet channel. The other channel is a wired channel through which the data is sent through PLCC or OFC mode. Parallel communication and optical fiber are also modes which are wired data, and through PLCC panel, line matching unit, wave traps, coupling capacitors, this data is sent all the way to load dispatch centers, and this is the other channel. To be precise, the wireless channel or internet media is the main media. The billing data is sent through this media of internet, and the data which is same data is received through PLCC panel, but that is a standby data. In case the data is not available through wireless media, the data can also be available through PLCC mode. So this is the way how data communication takes place. Sir, next please. Next slide, please. So these are the things which I have explained at energy meter, RJ11 connector, Modbus, data concentrator, router, modem, local server, and CMS server. So we'll go to next thing. Now, ensuring security in smart grid is important because it is connected extensively to other grids, and we don't know who are the people there, and therefore the authenticity or security of data cannot be guaranteed. Therefore, it is necessary to have cryptography or cybersecurity measures to be implemented in smart grid. Sir, next please. So this is a basic way of writing client-server program. There are two programs. One is client-side program, other is server-side program, which is very simple as it is written in Python. Python is a very simple but very powerful language used for data communication and client-server programming. Earlier languages like C, C++, Java were to some extent concept and difficult to understand. Thanks to Python programming, which makes it extremely easier to write code for data communication. So let us have client-server program. I will briefly introduce. That is, first is import. You have to import socket library, which is there in the Python library. That library covers all the protocols and all the functions related to data communication. Then there is a main function, which is the main part of the program. So as I explained, it is an IP address, which is specified. IP address of the device to which we are going to send data is mentioned as IP equal to, here it is 127.0.0.1, and port address is something 5000. So as I told, IP address is a dot code. These four numbers are separated by dots, that is dot code. And the port address is also provided in terms of number 5000, which is a hexadecimal. It is a hex code, and 16-bit code is there for mentioning the port address. There are input port, output port, and which are identified by assigning port address. So I have to assign IP address and port address, the location where I am expected to send data. S is the variable which is equal to socket.socket, means it is a, I am defining socket so that it will be connected directly at SLDC. And these are the configurations. And s.bind is the function which binds IP address and port address of the receiving end. And then I will send data and address. As I have told you, data and address are sent so that the UDP or TCP will understand where to send the data, and then they will decode the data. There are two things, decode and encode. Encode means whatever data is there, that has to be encoded. For example, if the data is 400 kb, 1000 ampere, then that data will be encoded in some form which is not readable. So that is called encode. And decode means again bringing back to 400 kb, 1000 ampere. So these are the things required. And print, and we have to print the data if want, and close the file and call the function, which is very simple. If it is a C program, it takes at least 2 pages. If it is a Java program, it takes at least 2-3 pages to write the programs, only server-side program. But it is extremely easy to write such programs using Python. Then client-side program is also there, which is similar to server-side. We have to import socket libraries. We have to assign IP address, port address. Now, in this case, I have mentioned IP address is same. The reason behind IP address for server and IP address of client is same, because the reason is I'm using my laptop, which will work client as well as server both. It will play both the roles. If one computer plays both the roles, then the IP address of that computer will be same. But the port address will differ. One will be working as a client and other will be working as a server. So in this way, client-server communication takes place. We have to write the server addition here, the server configuration, and again same thing, bind, then send the data. Input means you have to enter the data to be sent to SLDC. For example, I want to send some data from meter itself. Then I can connect meter port to that location, and it will need not type it. It will send that data continuously. So same while the loop is there. So till Q is there, Q means quit. Unless I quit, this will continue to send data. S.send to means it will send data to the other end. So in this way, client-server program will operate. They will work. So one is server and other is client. So server starts first. When you have to establish communication between client and server, the server will start first, followed by client. So server will start, and after starting server, it will wait for client request. Then client will be started, and then it will send request to server regarding sending of the data. Client will ask server that should I send data, substation data to you? Server will send okay, you can send, and then data will be continuously sent to server without any interruption, unless Q button is pressed. So otherwise it is a continuous communication without any interruption. So this is how the simple client-server program works. Next, please. Yes. Now we'll come back to our main subject, that is cryptography. So cryptography I mentioned as it is the encryption of the data. So crypto means coding and graphy means text. So they are coding the text, that is cryptography. So against cyber attacks or damage or unauthorized access, cryptography plays very important role. And cybersecurity, having cryptography as a part of cybersecurity is important from this angle. And the main thing is forging of data or stealing of the data or insertion of virus. So these things can be prevented by using cryptography. So it is the method by which data communication is performed using coded messages. So you have to code the message, and that is called encryption. Next slide, please. Yes, thank you. So the data to be sent is called plain text, and then it is encrypted, and the encrypted data is called ciphertext, that is coded data. So in this way, at sending end, the plain text is converted to ciphertext by using encryption, and then it is sent to other part, and that is coded. At the other end, it is decrypted and again bring back to the plain text. So this is the simple way how the encryption and decryption takes place. So in this way, cryptography has got two functions. One is called encryption, that is coding, and the other is decryption, that is decoding. And that will continue to take place without any interruption. The cryptography is not new. It is thousands of years ago. Even not thousands, but very ancient, I can tell, because Julius Caesar was the person who developed cryptography during wartime. The message to be sent to spies in the enemy group, so he used to encrypt it by providing some crypts. For example, if A's letter is there, then he would like to write fourth letter, A, B, C, D. So instead of A, he will write D. Instead of B, he will write E, and so on. So in this way, this cryptography is the first cryptography which was adopted by Julius Caesar. And then it was continued. Now, during wartime only, at that time, cryptography was there. Next, please. Thank you. So this is the simple program for cryptography. If you want to encrypt the message KVARH, and it is very easy. First, I have to define alphabets A to Z. Then I have to define key. Key means number of places to be sent. Second is, let us initialize, encrypt and decrypt. So initially it is 0, blank, because there is no encryption. Then I will use for loop, and I will find out the position using find command of each message. For example, K, I will find out the location of K, and then I will add 5. So instead of that location, it will go to 5th position. So it will change, and then I will encrypt it. So after changing the position, it has got some other alphabet. And if you continue this process, then instead of KVARH, now it becomes PAFWM by sending at the 5th position. So this is how simple cryptography takes place, which is a Caesar cipher, which is called. And at the receiving end, it can be encrypted in the same fashion. Instead of adding 5 places now, I will come back. So I will subtract 5, and again I will come back to the first digit. If it is D, it will be A, and so on. So something like this. So it will be decrypted again to the form KVARH. So in this way, this is called encryption and decryption, which are the two functions. In case of encryption, what we have done is we have encrypted the message by adding 5 and alphabetically going to the 5th position. And at decryption, again I am removing 5 and again coming back to the same position. So this is called simple cryptography. So as to understand, nobody uses it practically because it is very simple. Anybody can, any expert can decode this message. So this is for example only. Next, please. Now there is something called common key. Common key is the same password at sending end and receiving end. So there is no change. For example, again same thing is alphabets are decided. Then encryption directory is formed by coding having some value, some code is assigned. It can randomly also assign code or can generate the code. And this code value is what is called as a key. And if I enter that key, then only I can decrypt the message. The key is common, code value is common, as you can see here, that for encryption there is a code value, and for decryption also there is a code value. So when the common code is there, that is called common key. And the person who is sending is knowing what is code value, and at the other end, the receiver also knows code value. And then it is called common key, or it is synchronous communication, or synchronous encryption, or synchronous cryptography. So it is a common code or common password, you can say, through which the data is sent. For example, in this case, I have sent billing data as a code, as a plain text. It is converted to this code using decryption, which is called cipher code. And again, it will be brought to the same thing. Now, if you go to next slide, please. So it will again come back to the code, that is billing data, after decrypting. So this is common key, which is synchronous key. This is a very good example of how cryptography takes place. Sir, next slide, please. Yes. As you can see that this is a very excellent example of how cryptography takes place. So this is a straight way from which message M is to be coded, encrypted and sent back. So this is a straight path, feed-forward path, where message M is encoded by encryption key EK. And again it is sent and decrypted by the key DK. And again original message is obtained. So this is a normal path, or it is a common code, which is called synchronous communication, which is having same key is same, and the cryptography is carried out. Now, how the data is stolen? There are two ways. One is called passive attack. So the miscreant or intruder will be having some tap at any path, and he will steal information. If he knows the IP address, port address, and other details, he is able to steal this information, and then he will have this information at his disposal. So this is called passive attack. Passive attack is not harmful to the system, but it cannot be detected easily. That is a problem. If somebody is stealing the information, hacking some information, then we are not in a position to understand that it is being hacked. Very difficult to search such intruder unless you change your IP address, port address, and authentication. Then it is possible. Therefore, the way to prevent from encryption, from theft, is always changing the passwords randomly, changing the authentication randomly. So this is a passive attack in which the data is clamped out from the path, taken from the path. The other is active attack, which is dangerous. In case of active attack, they will have some link, they will have access to the data, and they will form the function FC. As you can see earlier, it was EM. So now C is a ciphertext, and fraud ciphertext FC they have created. They have forged it. They have made some changes. If it is a billing data, they will tamper that data, and then it send back to the receiving end. So at the receiving end, again, it is decrypted at C dash instead of C, because C is the original address. C dash is a stolen or modified address, and the receiver receives the data which is stolen, which is a fraud data, which is a forged data. So this is a very difficult, this is very risky operation of active attack. But because of new technologies, it is easier to detect such type of attacks. Active attack can be easily detected as compared to passive attack. Passive attack takes time. It is difficult to understand that there is a passive attack. So this is regarding active and passive attack, which play a very important role in our cryptography. Next slide, please. Please, next slide. I have explained this part. Yes, thank you. So there is a other way to send data. If I have to send the message that contract to buy 300 gigawatt hours from ABC Engineering Company, this I want to encrypt. Then first is I have to convert to the plain text. In plain text, I will remove the blank spaces that are there between the sentences, and one complete sentence is formed. And the key, I can use any key here as an example. The key purchase is used. So purchase is the key. If A is 1, B is 2, and so on, then the code word becomes 58624-173. Then I will write 1, 2, 3, 4, 5, 6, and then alphabetically I will write purchase as A first, then 2 is C, 3 is E, and so on. So in this way, instead of purchase, now the keyword becomes ACEHPRSU. Now I can send the data serially by writing the number. For example, 1 is corresponding to ATD SG NY. So 1 is corresponding to ATD SG 1Y, and so on. So I can shift this data from one way to other, one place to other. So this is the other way to encrypt the data, which is having common key. Purchase is the common key. Next, please. This is the other way of formation of data. The common key is one-time pad. One number is given, long number is given. And if you want to encrypt the number hello, then I will convert all the letters into ASCII code. ASCII code, as you know that, ASCII code is a 7-bit code. There are 127 codes for small capital numbers. Then numbers are there, some symbols are there, and that is ASCII code. So these are the ASCII equivalents which are available even on Google also. You can search ASCII codes. And these are the characteristic. OX is a prefix. OX stands for hexadecimals. So in this way, I have converted to ASCII codes. ASCII code in binary is also converted in a binary number. From hexadecimal, it is converted to binary. That is 0 and 1. The full form of ASCII is American Standard Code for Information Interchange. That is ASCII. And one-time pad is there, which is now we have defined this pad, which is a common key or which is a synchronous key. So I have mentioned here key, and then I have performed the XOR operation between these two numbers. So XOR stands for exclusive OR operation. As you know that XOR output is 1 if and only if only one input is 1, if there are two inputs. So in this case, 0, 0 means 0 because there no one input is 1. Here one input is 1, it becomes 1, and so on. So this is the XOR output of the code. Again, it is converted to ASCII code using the table. For example, A is 41, as you can see here. A is 41. So it is again becoming 41. And instead of hello, now the number becomes something different. So in this way, the encryption is done by using common key or by using a synchronous type of cryptation. Next important thing is, sir, next please. Yes, the next important thing is a asynchronous key, which is more practical and more secure. Because if common key is known to somebody else, he can easily have access to the data. But in case of asynchronous, it is slightly complicated, as I tell with this example, that there are two companies, ABC and XYZ. ABC company is assigning the task of machine learning analysis to XYZ company. XYZ company is performing machine learning instead of data matrix and other things, data science they are using, and they are converted into machine language model. So first the data is sent to the company by converting it from common key, or even they can use both the keys, and now they will perform. XYZ company will perform the analysis, and the analysis report is again sent back to the ABC company through public key. This is the public key. There are two keys, public key and private key, in case of asymmetric type of data transfer. And at the receiving end, the receiver, means ABC company, will receive the data by operating public key, but data will not be accessible unless he provides private key. After private key application, then data will be available. So I'll explain once again. If the data is to be sent from, let us say, XYZ to ABC, be brief. So then there are two keys being used. One is called public key and other is called private key. So public key, using public key, that this is a public key. Using public key, the data to be sent is sent to the ABC company, and ABC company is having private key. So ABC company will apply public key, but data will not be accessible unless he applies private key. When he applies private key, then the data will be accessible and the user will be able to have access to that data. So this is called asynchronous type of cryptography, which is very common and very practical as compared to synchronous. Next slide, please. So this is the example of public encryption, how it is done, how public and private keys are encrypted. So we have to choose two numbers P and Q. So let us say that P is equal to, we can choose arbitrarily 11 and 3. Then we have to perform product of P and Q, that is 33. Third is we have to this is n equal to 33. Then third is z, which is p minus 1 into q minus 1. So 33 minus 1 is, we can calculate here and find out the result. So 11 minus 1 is 10 and q minus 1 is 2. So 10 into 2 is 20. So in this way, I have got two parameters. One is n, which is 33, and other is z, which is 22. I hope this is clear. The third step is we have to arrange the integer e. We have to select e. That is not relative prime to z. Z is 20. So any number which is not having common factor with 20. So let us say it is, I will take the same example. So in this example, they have taken e as 7 because 7 is not divisible by 20. So 7 number is selected, which is relatively prime to z, that is 20. And then the product e into d can be performed, that is mod z. So which is e into d minus 1, and that is integer multiple of z, means it is remainder and division relationship. So in this case, it will be 1 and 20 because 7 into 3 is 21. Division is 3 and 20 and 1 are remainders. So 20 plus 1 is 21. So in this way, it is converted and message M is given as a ciphertext. And now we have to find out the keys. So the public key is E and N. Combination of E and N is a public key. So we have found out E to be 7 and N to be 20. So 7 and 20 combination is a public key. 7 and 33, it is E and P. E and N, N is 33, sorry, and E is 7. So these are the public key combination. And private key is a reverse way, that is D and N is a private key. So E is not there, instead of E, D is there. So in this way, we can form public and private keys. This is an example. There are a number of ways, number of permutation combinations. These are not standard ones, but still some standards are there, which are having some common things together. So in this way, the public and private key are defined and sent. Next, please. Now there is some algebra related with key combinations or codings. For example, if I want to add A and B, two things, then it is the same as encryption of A plus encryption of B and decryption of both the things. If I want to send two messages, A and B, then I can encrypt message A, I can encrypt message B, and after combining, I can decrypt it so that I will get A plus B. So this is one algebra which is very important while following cryptography. The other thing is, if I multiply message A by some scalar, if I multiply A by some number, scalar quantity, then encryption of A into that scalar, if I decrypt, it is the same as message A into scalar. So these are algebraic rules which are always there, which are followed for having number of things to be done, like calculations or manipulations are to be made. So this type of things are always required there. Next is, what are the standards for cybersecurity which are used in encryption? I'm not talking about all cybersecurity standards because there are so many. And the main are IEEE 1686. That is IEEE standard for substation intelligent electronic devices, IEDs. IED, as you know, is a similar to RTU, that is a remote telemetering or telecommunication unit, which performs sensing of the data, converting into digital form and sending it away. That is IED. IEDs are provided at number of locations, like circuit breakers, to know the status of circuit breakers. These are provided at the CTs and PTs, secondaries, to measure what is the current and voltage of the things which are connected at secondary side. So the rules and regulations or norms, or what we call as the standard related to these IEDs, is defined by IEEE 1686. That is a cybersecurity capabilities. name is cybersecurity capability. And if you want to design some cryptographic message, cryptographic environment, then you have to follow IEEE 1686 standard. And second is IEC 62351, International Electronic Commission 62351 is power systems management and associated information exchange. So there are things regarding data and communication security mentioned in this standard, which is called IEC standard, and that will have more coverage on these communication aspects. There are other standards also. That is IEC 685 is there, which is for metering equipments. Then there are few standards. VED is there. Then NC standards is there. It is American National Standard Institute, NC. So for particularly devices like numeric meters, then IEDs, or assigning IP address, port address, NC has given more coverage that how to select. And since the IP address is unique, it is important to select IP address, so that only that at that unit the data will be sent and not other devices. So in this way, these are the standards. And the book which is used here is, I have used this book. I found that this book will be very easy. Sir, next slide, please. Yes, these are the standards which I explained. One is IEC 1686, which is a cybersecurity capability standard that will take care of IEDs, then RTUs, PMUs, and other equipments. The other standard is IEC 62351, which just I have explained. It is related to power system management and associated information exchange. So all the data communication, data exchange, and protocols are mentioned in IEC 62351. The particular, as I told you, that transmission control protocol, TCP, and unified datagram protocol, UDP, are the two important protocols which are there required to be followed while forming this environment of cybersecurity or cryptography. Sir, next slide, please. This is the book which I have used, and very good book on smart grid. Particularly, one separate chapter is there on encryption or decryption, cryptography of smart grid, in smart grid. Very nicely explained by Wiley Publishing. And I have taken some examples from this book also. And there are a number of books, but I found this book to be very easy to understand and practical for practical implementations. Sir, next slide, please. Yes. So this coming to the end. This is the end of our slide, and I hope that you have understood. I tried to cover the large topic in a small amount of time. Particularly coding, lot of coding is there. You should know Python. Python is a very important language for encryption, particularly. In fact, Python is used for a number of applications like database management, or for client-server programming, for encoding, for communication, and number of things are there. And Python is a easier language compared to other. Python has got large libraries, large number of set of libraries which cover almost all functions. Then they have got very good features like Python Keras is there, Python Pandas is there. So Python Keras means they have got some applications of database management or formation of tables. Even Pandas also, we can use a number of additional features in Pandas. We can define our own functions using Pandas. Then Python, scientific Python is there, SCIPI, which can be very useful for performing scientific applications, like big scientific application like load flow analysis. It is difficult to conduct load flow analysis by writing simple program. So if you use these libraries like SciPy or other things, pandas and keras, then it becomes very easier to write the code. And even cryptography also, Python plays a very important role. The tool for Python is, I think, Google Colab. Google Colab is as name indicates, is a Google collaboratory, and it will provide you the platform to run any program, any Python program. Just you have to go to Google engine, search engine, and type Google Colab. Colab stands for collaboratory, and the screen will be developed, open, and select new program, or they call notebook. So if you select new notebook, then the screen will be available to you, and you can write any program. And that does not require any installation, does not require any configuration of your system, does not require any platform like Windows or Mac, anything. Nothing is required. It is totally open source, free of cost, and you can run any number of programs using Google Colab, particularly for machine learning applications. Google Colab is extremely important and extremely useful. The thing is that you should have only internet connection. Provided Wi-Fi is there, interconnection is there, Google Colab can be run from any end without installation. Just go to Google search and type Google Colab and select new notebook or open notebook, and click on type the program and click on the icon, run icon, and you can easily run that program and see that you can get results. And there is a auto save features that your file will be saved automatically. You need not click save button every time. Once you run the program, it will be saved automatically in your Google Drive. Google Drive, it will be automatically saved. If you have not installed Google Drive, then Google Colab will request you to configure Google Drive and then run the program, so that it will be installed there. So this is all about cryptography. I hope you understood this, and I thank the organizers of this platform, particularly Santosh Kawariji, for giving me opportunity to have interaction with you. If any questions are there, most welcome. Now question sessions will start.
Yeah,
any questions, please?
We will unmute all the participants so they can ask their queries directly, or you can write in chat box also. So just we are unmuting. Yes, now unmute option is there. You can unmute and ask the query.
Hello.
Hello, yes, please.
Good morning, sir. My name is Nikhil. Hello.
Yes.
Actually, I work as a security substation.
Okay.
And thank you so much for giving a brief introduction in short time.
Yes, sir. Thank you.
I have two queries. First one is, can you elaborate on AMI-based technology and how it will be useful in future? Two-way communication.
Yeah, AMI based. Just now, it depends on how long it takes, because the company AISSMS have already started thinking of undergoing AMI. That project will be also there soon, and it is really beginning of the smart grid.
Okay.
At present, it is a AMR stage, so it will take some time to go to AMI stage. That is advanced metering infrastructure.
Yes, sir.
So the grid will become more extensive and more complex. So in that case, cryptography will play important role.
Okay.
Yeah.
And so can you suggest some good books for Python, beginner Python?
Yes, by Python programming, there are a number of books. If you send your, I got my book.
Okay.
I've written one book on Python. If you send your email ID, I will send PDF, which is free of cost.
Sure.
And you can read and ask any questions if you want.
Yeah, sure.
Please send your email ID. I will send my book, which is only for beginners.
Yeah, only for beginners.
Beginner's Guide to Python Programmers.
Okay.
And it is very simple, and only I will send PDF, which is totally free of cost. So you can go through and ask any doubts.
Yeah, sure, sure, sure. Thank you so much, sir.
Thank you.
Good morning, sir.
Good morning.
Sir, what are the guidelines which are given for this cyber security? Are there any guidelines provided?
Guidelines means these some standards are there, which I have told about. IEEE 1686. They have given guidelines for IEDs, how the ID should be configured, how the port address should be configured. And there is IEC 62351, which covers regarding communication, how the protocols like TCP and UDP are to be developed, and so many things. So IEEE standards are only means they are authentic guidelines. There are other also other agencies, but IEEE, I think it is a standard one and easier to understand and implement.
Okay, thank you.
Hello, sir.
Hello.
Sir. Sir, my name is Prakash Mishram, sir. I'm from Eton Electric Corporation.
Yes.
And this is a wonderful session, sir. Thank you, sir.
Thank you so much.
Thank you.
Thank you.
Sir, actually, I want, sir, can you explain about the implement status about this security system in grid?
Implement.
Implement.
Now at this stage, it is not implemented in India, I think, or in Maharashtra.
Okay, sir.
In near future, definitely, future belongs to cyber security and cryptography. Once there is a AMI, advanced metering infrastructure, then these things will be coming in picture. Not today, because today,
Okay,
to some extent, it is a secure communication which is there from substation to SLDC. But when the system will become complex, then in that case, it will be felt necessary to implement these things, cybersecurity and cryptography.
Okay, sir. Thank you so much, sir.
Thank you.
Sir, I am Anjali Dharme. I just
Yes,
want to ask you whether in US or Europe, I mean in developed countries, whether it is already implemented.
Yes, madam. In the US or even Germany, these countries, they have already got cyber security, not only cryptography, but cyber security also.
Oh.
And their systems are running on this platform of cyber security.
So perhaps it will be a part of education in power system.
Yes,
It has to be for next generation.
yes, definitely. Yes. Few requisites are there, which may be new for electrical engineer, but they are required to be, they're easy to grasp, like IP address, then port address, and this Python language or client server communication. But these are not difficult for an electrical engineer. It is easy to grasp.
Anyway, other software they are using for load flow, etc. So
yes,
I think it will be easier for them, but this subject should be included in at least at MTech level.
Yes, ma'am. Yes.
Thank you, sir, for the wonderful session.
Thank you for attending. In a short time, I gave a message here.
No, sir. I know that always your lectures are very informative and useful.
Thank you so much.
Thank you. Thank you, sir.
Thank
you. One query is there, sir, in chat box.
Yeah.
Just I am reading it.
Yes.
Sir, as we know, cybersecurity is prime concern in wireless data communication. Why we are not using our own secure PLCC or OPGW communication channel by overcoming the problem of speed, storage, memory with advanced technology?
Yes, good question. Now, this is to some extent, this is a policy matter, whether to have wireless mode or wired mode. Both are there, and equally there are pros and cons of both the things. And in practice, there is a coexistence. Means wired and wireless, they are not replacing each other. They will not be competing each other. They will have peaceful coexistence. So both the systems will be there. As I told you that the billing data is sent on wireless mode, whereas the standby data, same data, is sent on wired mode, that is PLCC or optical fiber. So it is the policy matter which billing data, which will data to be created or to be considered as a billing data. So that is a policy matter, but the both systems, in my view, are equally capable of sending data. In fact, there may be complex existence of both the system. Some part may be wired data and some may be wireless. That can hybrid system will be also there in near future. So hope that my explanation is understood.
Okay. You can ask your further queries.
Yeah.
Otherwise, we can close this session. I think there are no more queries.
Okay, sir.
So, thanks to Dr. Bakre sir for this wonderful presentation. So,
Thank you, sir.
really, it was very nice presentation because as a power system engineer, we came to know that how much importance of cybersecurity, cryptography, how much that importance for electrical engineer is. And we are really thankful to all the participants for their active participation in this today's webinar. So all are welcome for this platform. Again, there are many more webinars daily we arrange. So once again, thanks all of you.
Thank you very much. And will you please send us recordings?
Yeah.
Thank you.
Yeah. So
you can also send, you may also send my presentation also.
yes,
You
your
may
presentation.
circulate. No
Yes,
problem.
sir. I'm sharing in the forum also.
Yes.
Yeah. And if anyone want to join the forum, just
How
send
to
the
join?
send the request on WhatsApp, so you can
Okay.
join the forum.
Okay, thank you.
Yeah. Okay.
So, shall I leave meeting, sir?
Yes, sir. Now we can close the session.
Yes. Thank you so much.
Yeah. Thank you, sir. Thank you.
Yes.
Yeah, thank you, sir.